So here, this says sketch the graph, and this is in slope-intercept form, which is y equals mx plus b. In this form, this is actually the slope. That's the slope. M equals slope. So in this case, so many people do this. It's negative 1/2, not negative 1/2 x. If I asked you the slope, you do not include the x. The slope is just the coefficient in front of it. And then the number that's over to the side, that's going to be part of the y-intercept. Remember, for the y-intercept, x, the x is always 0, so this would be 0, 6. So it's really easy to graph this, because all you have to do is plot this and then follow your slope. Like Toucan Sam, you follow your nose, except for this is the slope. The slope is the nose. Okay. So if I have this, and I want to graph this line, you can't see that, graph this line, then all I have to do is first start out with the y-intercept. So I'll plot the y-intercept, which is 0, 6. 1, 2, 3, 4, 5, 6. So there we go, 0, 6. And then I follow my slope. Remember, negative slopes mean I'm going downwards from left to right. So this negative implies that I have to go down 1, and then over 2. If I went backwards 2, I would get a line like this, watch. So this is incorrect. If I went down and then back 2, I would get a positive slope because it's going upwards. The guy would be climbing up. That's just one long arm, no legs. He would be going up the hill. So I know that it's negative, so I must go down and over to the right. So that would be down 1 over 2. And there we have it. We graphed it. We did it. That's it. We did it, Reddit. We did it. So that's how you graph stuff from slope-intercept form. I think that's the easiest way because you don't really have to do any calculations. Just look at it and go. So just careful with the negative and the positive slope, and you'll be good. Let's take a look at that number 10 because that was a weird one. Because if you tried to graph that with intercepts, you might get messed up. So I'm going to do something similar. 3x plus 4y equals 0. Okay, so it's not exactly the same, but it's close. The similarities are that we have equals 0 on the right side, and that's pretty much what determines like why we can't really do this one that well. So if we tried to use intercepts, we could say x-intercept, that's when you make y 0, so that goes away. And then 0, so what would we have left? We'd have 3x equals 0. Divide by 3, my stomach is growling. Divide by 3, x equals 0 still. So that would be 0, 0. 0 for the x, because we just found that. And 0 for the y, because we made it 0 for the x-intercept. So that would be 0, 0. The problem is, when we make x 0, the same exact thing happens. We get 4y equals 0, divide by 4, and we get y equals 0. So the x and y intercept are actually the same. That's amazing! It's blowing up my brain. No, it's not. I've seen this before. So have you, probably. So the x and y intercepts are right here. I only have 1 point. It could look like this, it could look like this, it could look like that, it could look like this, like that. I don't know. I don't know what it looks like. So we had to do something else. And that's because we had a 0 there. So what else do we do? Well, let's start with 3x plus 4y equals 0. We're going to make it look like y equals mx plus b. So we're going to make it look like this, because then we could just look and graph it. So that's what I'm going to do. I mean, you might already know how to do this, but the y is all by itself on the left side. Well, the y is on the left side. So I will subtract 3x to both sides. And then I have 4y equals 0 minus 3x. You could write the 0, but it's not doing anything. It's just nothing. So you can just write 3x. You could say plus 0. That's fine, right? Because you could even say minus 0 because 0 is negative, positive, neither positive nor negative. But I'm not going to do that just because it's extra writing. So and then I could divide by 4, and that goes away. Why? Actually, maybe I will do it. 3x over 4. I'm going to say plus 0. like I had before. You could say minus 0 as well. Then, what do I know now? I know that this is the y-intercept. Okay, good. I already got that. It's also the x-intercept. But you can't really, I mean, I guess you can tell, but yeah, there's the y-intercept, and then here's my slope. So I just count it. Down 3, 1, 2, 3, over 4. 1, 2, 3, 4. So down 3 over 4. Now, here's what I see, some mistakes that I see all the time. First, you're supposed to plot this. So I see that. People go, okay, I plot that, I'll plot it there. And they plot it there. And that's all fine and dandy. And then, like, oh, now it's time to follow the slope. And you know what they do? They start from back here, and they go down 1 over 2. And then they connect those two points. And they get this. That's definitely wrong, because the slope has to start from the y-intercept. Otherwise, you're not actually getting the slope, because if you started here and went down 1 over 2 and did this, the slope is supposed to be negative 1/2, right? Yes. But if I actually counted the slope of this black line, that's way, way more negative than negative 1/2. That's 1, 2, 3, 4, 5, 6, 7, 1, 2. That's 7 over 2. So that doesn't work out. You definitely have to, no! That was the bell. It's lunchtime. You definitely have to start from the y-intercept, so you got to be careful with that. So that's how you sketch those graphs. I'm going to be done now.